everyone. I am Kusa Raju, currently pursuing my Masters in Signal Processing and Communication at IIT Tirupati. Today I am here to give a paper presentation on a variant of RANSAC as a part of computer vision course. Before going to the what is the title and what is the concept, let's get into a brief discussion of RANSAC. RANSAC, which is short for Random Sample Consensus. It is an iterative method to find the parameters of a model. As the name suggesting, randomly we will choose a sample and score it. We will find the score of that sample. We will iteratively do for some certain number of times. Among all the number of samples, the sample which getting the more consensus, that one we will take as a then final thing. Then why we came for RANSAC? Model fitting. Model fitting is a fundamental problem in computer vision. Model fitting means finding the parameters of the model that best fit the data. The model can be as simple as a 2D line, as complex as some 3D object too. Let's go into some details of the RANSAC. Earlier we said that we will go in it iterative process. How many times we should iterate? That is given by this formula. Here we can see epsilon. Epsilon is proportion of outliers. S is size of the sample, that is number of points required to construct a model. P is the probability of success. N is the number of samples we want. We can understand this formula in this way. Here epsilon is proportion of outliers. 1 minus epsilon is proportion of inliers, or probability of a point being a inlier. 1 minus epsilon whole power s is probability that all points in a sample will be inliers. 1 minus probability of all whole sample becoming inliers is probability that there will be one point that will be outlier. So 1 minus epsilon whole power s will be probability that a sample will be contaminated. Whole power n is probability that all n samples will be contaminated. 1 minus all samples will be contaminated means probability that at least we will get a one sample that was not contaminated. That is, it will have the inliers, which is equal to P, probability of success. Here in this, from this equation we can calculate n value. Here in the starting we know everything. P, probability of success, how much confidence we want to have. S, what model we want to construct based on that size of the sample. Epsilon and capital N we don't know. So initially the standard RANSAC it is taken as some 1. That means 100% are all outliers. So iteratively, first a sample will be taken, a model will be evaluated for that sample, and number of outliers will be calculated. If number of outliers in the present iteration are less than the previous iteration outliers ratio, then a new value of n will be calculated. Actually, in the starting, when epsilon equal to 1, capital N will be equal to infinity. But as we are going iteratively, based on this epsilon value, n value will changes, and we will keep track of all those iterations we have gone so far. Whenever these n crosses number of iterations, that is, whenever n is greater than number of iterations we have gone so far, the process will be terminated. Then after terminating the process, what are all the samples we have taken so far? From all the samples, which sample having the more consensus, that means which has more inliers, will be taken as final sample. It has so many applications. RANSAC is one of the widely used in computer vision. Suppose here some of the applications are mentioned: image stitching, creating a video mosaic by finding the geometric transformation between two frames of the video, image rectification, which is projecting all images so that they will come to a same image plane, and estimating a fundamental matrix, which is used in finding the depth of the object. For example, as a human being, how we are finding the depth of the objects based on the difference of views in our left eye and right eye. In the same way, using two cameras, this process will be done. There also, this RANSAC will be used. So, because of such a high usage, people composed a song also on RANSAC. We can watch it in YouTube. Let's go further. So, for all the above applications, the RANSAC is the predominant method with its variants. The standard RANSAC was published around 40 years ago. Over the years, the method was investigated and new methods came up to improve the method in the speed wise, accuracy wise, like that. Few of the methods are MLE-SAC, maximum likelihood assay, sample consensus; PRO-SAC, progressive sample consensus; LO-RANSAC, local optimized RANSAC, RANSAC, so on. Many things came, many methods have been proposed over the years. In the standard RANSAC, all the correspondents are treated as uniformly. A sample is drawn randomly, a random sample in the uniformly, whereas in MLE-SAC and MLE-SAC, it is in non-uniform sampling based on some guided phenomena, some guided information they will take. In PRO-SAC also, based on the top rank correspondences, they will take the sampling. Whereas in LO-RANSAC, a local optimization step is included. In RANSAC, it was derived actually from Bayesian filtering framework. So and so many methods came. The method that I am going to present, it is also one of the method that came on RANSAC, which is Optimal-RANSAC Towards a Repeatable Algorithm for Finding the Optimal Set. It was published in the year of 2013 in the Journal of WSCG, Vector School and Computer Graphics. It has the citations so far 100 plus citations. These are the authors of the paper. Let's get into the paper. The basic idea of the paper is how to make RANSAC repeatable. Why? Why to make the RANSAC repeatable is, in some of the medical applications, while running the tests of other parameters in that application, it is difficult to use RANSAC because in each run the inliers will change because random, as the name suggesting. So RANSAC has to be repeatable in such applications. In some of the applications like homography, geometric transformations also, each time the homography will be different. So to answer all these things, these people came up with optimal RANSAC, so that RANSAC will be repeatable. Not only this thing, the standard RANSAC will not give optimal set at all cases. If number of outliers increases, it won't work good. If number of inliers are less than 50%, the standard RANSAC performs very badly. But the proposed optimal RANSAC method works better. Even the percentage of inliers is less than 5% also, less than 5% also. Let's get into the method. The proposed algorithm is based on several known methods. Some models are given. What is the stopping criteria? When should be algorithm should be terminated? After getting the set of tentative inliers, resampling, rescoring, and pruning to further better the set whatever we got. Let's get one by one. Here the stopping criteria is whenever the set does not change, then the algorithm will be terminated. Experimentally found that the proposed algorithm comes to the same consensus only when the set is optimal. Whereas in standard RANSAC, based on some statistical hypothesis, it will be terminated. We saw that when the number of samples required crosses number of iterations, it will be terminated. It is all based on percentage of inliers we have seen earlier. After that, resampling. Why resampling? In the tentative inliers we got, there are inliers in the set, but there are some outliers also. Those outliers should be removed. For that, resampling. When these people applied these resampling is when the inliers are more than 5, based on the application they worked on. Which it is different in LO RANSAC. There the resampling is applied when the standard RANSAC is given the what is the set got is best set. Then only resampling is applied in LO RANSAC. But here when the inliers are more than 5. How it is applied is performing the iterations. Here number of iterations are 8 on a quarter of the set. Whereas in LO RANSAC, there are 10 iterations on a half of the set. It is easier to understand how RANSAC performs on a straight line rather than many geometric transformations and so on. So let's see small example on straight line. Here see in the first diagram, the blue line is the model. It is a 2D model, which is a line. A blue line is a first in the first iteration what we got. These are the inlayers. Now we want to resample. Resample means already we have a tentative inlayers. In the tentative inlayers we are sampling again. Let's take in 2 points which are in blue color, which are enough to draw a line. Using these 2 lines, in the second iteration, one line, a black line is drawn here. You can see in the second image. Now compared to first line, the second line is a better fit. It seems. You can see more layers are there. Some of the points which are in layers earlier, they become outlier now, which is shown in red. Some of the points which are outlier earlier, they became inlier now, they shown in yellow. This is the use of resampling. The next one is rescoring. Rescoring is to increase the reliability of the model. By keeping the same tolerance, we iterate the set. we iterate the rescoring again and again until the set does not change. But in the process, sometimes the set will wobble between 2 sets. To avoid such cases, the number of iterations is put as a limit as 20 iterations. Afterwards, pruning. In the rescoring process that we have done by keeping the same tolerance, but by decreasing the tolerance, we can prune the set further. Pruning means removing the outliers or outermost inlier so that we get very best inlayers. This is the process. These are the results shown in the paper. These are the typical bone structure. The central axis of these bone structures are formed by proposed RANSAC method. See the same bone structure, there are the different other cases. These are the surface normals are represented as the points on the sphere. They worked with this method on some aerial images also, which are taken from the space. These are some of the references they mentioned. Thank you.